Okay.
This tutorial will show you how to graph a rational function using the graphical calculator. We've done this before in the past, but with a little bit simpler rational functions like 1 over x. The key to graphing a rational function is use parentheses. And what I mean by using the parentheses, consider the function f of x equals x plus 3 divided by x plus 1. On the calculator, we must input the information used in parentheses on the numerator and parentheses on the denominator so it graphs properly. So the format on the calculator is going to be parentheses x plus 3 close parentheses divided by parentheses x plus 1 close parentheses to ensure that the numerator and the denominator stay intact. To graph it, we graph it like it normally. We hit y equals, we plug this function in with the parentheses. So it'd be parentheses x plus 3 close parentheses divided by parentheses x plus 1 and hit graph. First, let's turn off the old stat plot. That would help first from the previous tutorial. So let me do that first, turn that off. Now we're going to hit graph. Okay, well let's put it in standard mode. So we do that by zoom 6. Now we're back in standard mode. That's what I want. These are all things we run into when we're going back and forth between regression and other operations with the calculator. You might have to play these little tricks to clear out the settings. Now notice, here's the correct graph. Notice there's two pieces and there's a line that it doesn't touch called the vertical asymptote. That vertical asymptote occurs at x equals -1. The reason it doesn't cross that line is because if you look at this function, the times that this function where the denominator equals 0 occurs when x plus 1 equals 0 or when the value of x equals -1. Since you cannot divide by 0, that is an undefined value on the function, which is shown as a vertical asymptote on the graph. Additionally, you have what they call horizontal asymptote this way, where the line doesn't cross. This occurs at y equals 1. It's hard to, even though the vertical asymptote is shown here, the horizontal you got to kind of eyeball. The way, as I showed you in class, algebraically you know it's x equals 1 because since the degree of the top and the degree of the bottom is the same, both 1, the horizontal asymptote is going to occur at the ratio of the leading coefficients, which is 1 divided by 1, which happens to be 1. I showed you that in class algebraically, but now I'm showing you how it applies graphically to the calculator. Second function, f of x equals x squared plus 3x plus 4 over x squared plus 2. If I graph that, to get more practice graphing the rational function, again we got to use parentheses. So the numerator is going to be parentheses x squared plus 3x plus 4 close parentheses divided by the denominator's parentheses x squared plus 2. That's how we put that in the calculator. Do that, hit y equals, clear out the old function. I'm going to replace it with this function. Parentheses x squared plus 3x plus 4 close parentheses divided by parentheses x squared plus 2 close parentheses, hit graph. Now notice on this particular function there is no vertical asymptote. It's a continuous, but it does not cross, in this case, the line 1 again. Okay? So, this will have a no vertical asymptote, but it has a horizontal asymptote at y equals 1. Okay? Doesn't cross to the bottom of that, doesn't cross below that, so everything is on the top of that. So here's an example where you have a horizontal asymptote, but not necessarily a vertical asymptote. It makes sense there's no vertical asymptotes because if I solve the equation x squared plus 2 equals 0, there are no solutions to that, which means there are no undefined values for x which implies that my domain is going to be all real numbers. On the above equation here, the domain was all real numbers except the values that make the denominator equal 0, which would be except x equals -1, which implied that there was a vertical asymptote at x equals -1. So this kind of shows, it ties in how the vertical asymptotes ties into the domain, and what it turns out to be is the horizontal asymptotes tie into the range of the function. So on both of these cases, here and here, my range R would be all real numbers except up here it would be y equals 1, and likewise down here it would be except y equals 1, because that's where the horizontal asymptote is. So the way the vertical and the horizontal asymptotes are related to the domains and ranges is the vertical asymptote is the exception to the domains, whereas the horizontal asymptote are the exceptions to the range. This concludes my tutorial on rational functions.